The objective of this lesson is to compare two fractions with different numerators and different denominators using benchmark numbers. To review, a benchmark number is one that is easily recognized and commonly used for estimation. In the previous lesson, we used 1/2 as a benchmark number. We also reasoned whether a given fraction was larger or smaller than 1/2. Today, we are going to add 0 and 1 as benchmark numbers when comparing fractions. When fractions are close to each other on a number line, it is helpful to be able to reason whether they are closer to the numbers 0, 1/2, or 1. For example, let's look at the fraction 7/8. Is it closer to 0, 1/2, or 1/2? Using a fraction model, notice with your child that 7/8 is 3 pieces more than 1/2, but it is only 1 less than 1/2. So 7/8 is closest to 1/2. We could also use a number line to compare the fraction. First, let's label our benchmarks. 0, 1, and 1/2 is right in the middle. Then we will partition our number line into a total of 8 equal sections to represent eighths. Notice that the 0 is the same as 0/8, then 1/8, 2/8, 3/8, and 4/8 is the same as 1/2. Continuing on with 5/8, 6/8, 7/8, and 8/8, which is the same as 1/2. Now let's mark the fraction we're comparing, 7/8. The number line is similar to our model in that it shows that 7/8 is 3 jumps more than 1/2, but only 1 jump away from 1/2. This shows us on a different model that 7/8 is closer to 1/2. Let's look at a different fraction, 1/3. Is it closer to 0, 1/2, or 1/2? Let's use pattern blocks to represent this fraction. If the hexagon is a whole, then 1/3 would be this rhombus because it would take 3 of them to create a hexagon. It looks like it is less than 1/2, but is it closer to 0 or 1/2? It might help if we break it into smaller pieces to compare. It takes 2 of these green triangles to make the rhombus, or represent 1/3, and it takes 3 of the triangles to represent 1/2. That means that 1/3 is 2 more than 0, but only 1 piece away from 1/2. So it is closer to 1/2. We could also see this on a number line. If we again label our number line with our benchmarks 0 and 1, with 1/2 right in the middle, then let's partition it into thirds and label them. Notice that 1/3 is 1 jump away from 0, but 1/2 is only half a jump, or half of 1/3 away from 1/2, showing that 1/3 is closer to 1/2. Using 0, 1/2, and 1 as benchmarks is particularly helpful when comparing fractions that are both greater or both less than 1/2. Take a look at the following fractions, 3/5 and 5/6. Let's use a fraction model to compare these. Both are larger than 1/2, but individually, are they closer to 1/2 or 1/2? Looking at 3/5, notice that it is half of a fifths piece larger than 1/2, but it is 2 pieces less than 1/2, so 3/5 is closer to 1/2. Now looking at 5/6, we can see that it is 2 pieces larger than 1/2, but only 1 piece less than 1/2, so 5/6 is closer to 1/2. Knowing this helps us to reason that 3/5 is less than 5/6. Let's compare one more set of fractions, 7/8 and 3/4. This time, let's use a number line. First, we will mark the number line with our benchmarks of 0, 1, and 1/2. Now let's partition it into fourths and mark where 3/4 is. 3/4 is 1 jump away from 1/2 and 1 jump away from 1/2. It's right in the middle. If I was rounding, when I reach a midpoint, I always round up, so I could say that 3/4 is closer to 1/2. Let's see if this helps me. Next, let's mark 7/8. To do this, we will partition the number line into 8 equal sections, and this is 7/8. Notice that 7/8 is 3 jumps away from 1/2, but only 1 small jump away from 1/2, so it too is closer to 1/2, but it is farther away from 1/2 than 3/4. Also notice that while both fractions are only 1 jump away from 1/2, the fourth jumps are much larger than the eighths, so 7/8 is greater than 3/4. Give your child experience comparing several different fractions and encourage them to explain their reasoning. The objective for this lesson was to compare two fractions with different numerators and different denominators using benchmark numbers. We met this objective by using fraction models and number lines to reason and compare fractions to benchmark numbers.